All right, AP Stats fans, our topic for today, we're going to start Chapter 9. Now, Chapter 9 is significance testing. So Lesson 9-1, this is day 1, this is coming from Stats Medic. Is this gender discrimination? So we've been talking about confidence intervals where we are estimating a parameter, whether that would be the true population mean or the true population proportion of a set of data. Now we're going to be getting into testing what we call hypotheses and making a conclusion of whether we can reject some statement or fail to reject some statement. Okay, so we're going to start off with a problem here. And the situation is a local engineering firm had to conduct a series of layoffs recently. They will lay off 10 people. The company has 180 employees that could be laid off. All are equally qualified, so the company decides to use a lottery system to be carried out by the manager to decide who will be laid off. The manager posts a list of the employees to be laid off. 5 employees are women, 5 are men. One of the women claims this is gender discrimination and starts a lawsuit against the company. All right, so again, take some time, read through that again. All right, so 180 employees, 10 of them will be laid off, 5 are men, 5 are women. Now, one of the women is claiming that there is gender discrimination. So, question number 1, the manager responds, how could there be gender discrimination when half of the employees laid off were female and half were male? What additional information do you need to evaluate this statement? Okay, so for each of these questions, you can try to fill them out on your own. So pause the video and ask yourself, see what your answer is, and then if you unpause, and we'll see if we agree. So in this case, what additional information do we need? Well, we would want to know what the original number of men and number of women, the number of males and the number of females that work at the company. Because if it's not 50-50, then getting 50% female and 50% male may not make sense if it's a fair lottery. Okay, so we need to know the total number of males and females that work at the company. That's going to help us determine whether this lottery was carried out fairly or not. Now, it just so happens that we do know the numbers, so after we've stated this, I will tell you that there are 60 females and there are 120 males at the company. Okay, so now maybe the claim makes a little bit more sense that only 1/3 of the company is made up of female employees, yet half of the people that are being laid off are female. Okay? So, number 2, how can you investigate the gender discrimination claim? Detail a process that could be used. So again, think about this for a moment and then unpause. Well, what we want to do is we want to run a simulation here. We would like to simulate the employees and choosing 10 of those employees and then determining, okay, what proportion of them are female. Now, we do know that, so 60 out of 180, there's 180 employees. So we know that 1 out of 3 are going to be female. So one thing we could do is a random number generator, where we say that we'll go from 1 to 180, and we would say that 1 to 60 would be female, and then 61 to 180 would be male. Now, we could run that on the calculator. We could, in this situation, roll a die, a fair die, roll 1 fair die. Remember, the numbers on dice are 1 through 6, and we know that 1/3 of the numbers need to be for the females. So we could say 1 and 2 are females, and then 3, 4, 5, 6, those would count as males. We could do a random number generator. We could just do numbers 1, 2, and 3, where if a 1 comes up, that's female. If 2 or 3 come up, that would be for the males. All right, so anyway, let's say that we go ahead and run this now. If we want to do this with the calculator, do the random number generator. So we could take the calculator. I would need to turn it on. And okay. Menu. This would be probability. We want random. And in this case, we would be doing random integers. Now let's say if I go from 1, I'll do this with the dice because it'll just be less numbers. 1 to 6, but I'm going to do this 10 times. All right, and then the numbers come up. So anything that is a 1 or a 2 would count as female. So I see 1, 2, 3 numbers. So that would be 3 out of 10. And 3 out of 10 is 0.3 as a decimal, okay, the proportion. Okay, so complete your investigation below. Now let's say that we've already done this. We did this a bunch of times, and I'm going to plot as a dot plot here the proportion that are female. So 3 of the times that I ran this, and I actually did this with a class last year, we had 0.1. And then for 0.2, we had 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. For 0.3, we had 7. 1, 2, 3, 4, 5, 6, 7. For 0.4, we had 7. 1, 2, 3, 4, 5, 6, 7. And then 0.5, we had 3. Now, before we interpret this, let's kind of talk about what we're trying to accomplish here. Okay, now, a claim has been made. The claim is that there's been some gender discrimination in making the choices here. Okay, so there are actually 2 things that we always write down here. When we are running a significance test, we're going to write down what we call hypotheses. The first one we always write down is called H0, or the null hypothesis. All right, we read that 0 there, H0, okay, or H0. The null hypothesis, we are claiming gender discrimination. This is what we're trying to find out. But the null hypothesis is what we call no news. So nothing out of the ordinary is happening. So for our null hypothesis, this is where we're going to start from. Our null hypothesis is that in this case, the proportion is that the true proportion, or we would just say in this case, there is no gender discrimination. That would be the no news. Now, that's not what we're trying to claim, but that is our starting point, is that, you know what, there's no gender discrimination. This just randomly happened that, you know, half the proportion ended up being 0.5 for the females, okay? Now, what we're really trying to show, though, is what we call the alternative hypothesis, which we label as H sub A. Now that is the claim that we want to show. The null hypothesis is that there is no gender discrimination. The alternative hypothesis is that there is gender discrimination going on. So the way we're going to show that is we run this experiment here. So we're trying to determine whether there is or is not gender discrimination. Well, when we look at our distribution here, the question is, all right, 1/3 of the employees are female, but we actually got that half of the females at the company, or out of the 10 that were laid off, half of them were female. Now that seems quite different from 1 out of 3, 33.3% versus 50%. Is it likely or unlikely for this to actually happen if this was done fairly? Okay, so our null hypothesis was that there was no gender discrimination, basically that this was done fairly. Now we know that when we take samples, there's always going to be some variation. So even though the true proportion here is 0.33, repeating, when we take a sample, we are not necessarily going to get 0.3 or 0.4. We may get something lower, like 0.1, where only 1 out of 10 of the employees was female. They got chosen to be laid off. It could be here that 2 out of 10 were female. It could be 5 out of 10. It could be even higher than that. So the question is, though, we know that there's going to be variation. How common is it for us to get the value that we actually got, which was 0.5? Assuming that this is done fairly, that by chance it just happened to be this way, the question is, how often is that going to happen? How likely is that? If it is highly unlikely, then that's going to support the alternative hypothesis. If it is fairly common to get 5 out of 10 in our simulation, then we're going to say, you know what? We can't really say that there's no gender discrimination. Or we can't really say that there is gender discrimination. If it's something that's going to come up just due to random chance, well, it could have been done fairly. If it seems unlikely that it came up from random chance, then we're going to say, you know what? We think there's something going on here, that this lottery was not fairly done. Okay, so we look at the data now. We look at the numbers. The question is, what percentage of the dots represent half or more females being laid off? When we run the simulation here, we're using a random number generator. So we are choosing these randomly. Now we got, when this was actually done, 5 out of 10 of the people chosen to be laid off were female. In our simulation, the question is how many were at 0.5 or higher. Now in this case, 0.5 was the most we got. Now we could get, if we kept going, maybe we could get 0.6, 6 out of 10 were female, or 7 out of 10. But in this case, 0.5 or higher would be 3 out of, and let's see if we count this up, 4, 5, 6, 7, 14, 21, 23, 26, 29. So 3 times out of 29 in our simulation, half of the people chosen were female. Half or more were female. And that is 0.103. All right, so how do we interpret this? Remember that our simulation has been done assuming the lottery was carried out. I'll write it this way. Assuming H naught is true. Assuming that the lottery was carried out fairly, the probability of getting a proportion of 0.5 or higher, in this case, due to random chance, is 0.103. Assuming that the null hypothesis is true, that this was actually done fairly, the probability of getting the results we got of 0.5 or higher due solely to random chance, that's why we use a random number generator, is 0.103, which is about 10%. Okay, so given the situation that we had here, 180 employees, 1/3 of them were female, the probability based on our simulation that half of the people laid off would be female is about 10%. Now that may seem low to you, but that is actually not significant. Do you have convincing evidence of gender discrimination? 10% is actually something that, it's not common, but it's not something that is really unlikely to happen. So do we have convincing evidence? No. And statistically, what we're going to be learning is that we would need this value to be smaller than 0.10. We'd actually want this to be less than 5%. If our simulation, if we ran our simulation and for the female proportion to be 0.5 or more, for that to happen less than 5% of the time due to random chance, then we would start looking at this very closely and saying, this does not seem to be the case, which means we would conclude this. Okay, but 10% is actually not enough. So we would say no, a sample proportion of 0.5 or higher happens fairly often. And this would be our conclusion here. Now, what we're going to be learning, we're going to be a little bit more official than this. This percentage, what we're getting here, this 0.103 is what we call a p-value. It's the probability that something is happening. What we're doing here is we are interpreting the way we interpret the p-value. Assuming that the null hypothesis is true, how likely is it for us to get a value of 0.5 or more just from random chance? Well, the p-value is 0.103. That's not low enough. It's not unlikely enough for us to actually reject this. So what we would say as our conclusion here, officially, we fail to reject the null hypothesis. And that's the end of part 1.